Hi, I'm going to talk here about residues, and I'm going to solve two integrals using kind of the very basic methods of residues. Nothing too fancy here. So the first integral I'm going to solve using residues is the integral of z e to the 3z around a circle of radius 4. That doesn't matter so much. And the way I'm going to do that is I'm going to say, right, this is going to equal to 2 pi I times the residue at, well, the only singularity here is at z equals 0. So that's all I'm going to do. So now the rest of this is just going to be devoted to figuring out what the residue is. So let's do that. I can do that by saying z e to the 3 over z is equal to z times, well, I know what this series is going to be. The series is going to be n equals 0 to infinity of 3 to the z to the n over n factorial, because that's what e to the z does. You just take the input, raise it to the nth power, do that. Well, this, if we simplify this is a bit, this is going to be 3 to the n over n factorial times 1 over z to the n, from n equals 0 to infinity. And so if we suck the z in there, we get n equals 0 to infinity, 3 to the n over n factorial times 1 over z to the n minus 1. So you notice what we want here, the residue is just when you get the term that's 1 over z. And that happens when n equals 2. So n equals 2 implies that the term is going to be 3 squared over 2 factorial times 1 over z to the 2 minus 1 implies that the residue at 0 is going to equal, that's 9 over 2. And now we just plug this in. 9 over 2, so that gives me 9 pi I, and I'm done with this integral. So all that I need to do is just figure out the series for the integrand. And once I do that, I just figure out what the coefficient on the negative 1 term is, and it's 9/2, so I just multiply that by 2 pi I and I'm done. So similarly, I'm going to look at this. Now this is 1 over z squared sine z, and this is going to equal 2 pi I times the residue at z equals, again, 0 is the only thing in this circle. This is circle of radius 1. Z, the only problem here is at 0. The only problem here is at n pi, but I made the circle small enough so that z equals 0 is the only case. So I just need to figure out what this residue is. And I can do this by going back to high school and remembering polynomial long division. So first of all, the denominator is z squared sine z equals z squared times z minus z cubed over 3 factorial plus da 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 equals, if I distribute that through, I get z cubed minus z to the 5th over 3 factorial plus da 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 da. Now, to figure out what the Laurent series for the integrand is, I know the denominator in terms of a power series, so I can just do polynomial long division, which is z cubed minus z to the 5th over 3 factorial plus da 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 goes into 1 how many times? Well, I can do the long division. I need to multiply this by 1 over z cubed to get that, and when I multiply by 1 over z cubed times all this, I get 1 minus z squared over 3 factorial plus da da da. Subtract it just like I do in division, and I get z squared over 3 factorial plus a whole bunch of other stuff. Now what I need to multiply, and now what do I need to multiply z cubed by to get this? Well, I'm going to multiply it by 1 over 3 factorial times 1 over z. When I do that, I get z squared over 3 factorial plus a whole bunch of other stuff, and I get 0. And notice now I just have, this is the residue. So I get 1/6, which is 1 over 3 factorial, so this is just pi I over 3. So I can use my high school skills to help me with this. All I need to do is to use polynomial long division on the numerator and the denominator, and I get that 1 over 3 factorial as a residue. I just plug it in there and I'm done.